So in this video, we are going to look at task 10, quadrilaterals. It is on page 31 and 33 of the original. Again, it might be a little bit different depending on how it printed. So first off, what is a quadrilateral? So we talked about this when we did polygons. Quadrilaterals are four-sided polygons. And there's two features I want to talk about before we get into the types of quadrilaterals. So one thing is quadrilaterals have diagonals. So in a quadrilateral, any like four-sided figure, a diagonal is a segment that connects opposite vertices. So every quadrilateral has two, and it's just a line in the quadrilateral that connects the opposite vertices, the ones that are across from each other. So when we talk about a vertices, when we do a quadrilateral, we talk about opposite and adjacent. So opposite in this one would be, if I'm talking about angles, I would say angle A and angle C, okay, or angle B and angle D. If I'm talking about opposite sides, I would be saying BA and AD, and I would be saying in this case, sorry, that's not right, BA and CD. And then I would be saying AD and BC. So those are all opposites. Then we talk about adjacent sides or angles. So adjacent means that they're next to each other. So when we're talking about angles, they are on the same side. So there's a bunch of pairs, but like angle A and angle B are adjacent. Okay, they are on the same side and they're next to each other. Angle A is also adjacent to angle D because they're on this bottom side. Angle D is adjacent to angle C as well because they share this right side, and angle B and angle C are adjacent. So those are all the adjacent angles in this particular diagram. If I was talking about sides, it would be kind of the same thing. They would be the sides next to it. So BA and BC are adjacent. That's this side and this side. They meet at vertex B. So they have to share a vertex if they're adjacent. BA is also adjacent to AD. And then let's see, AD is also adjacent to CD or DC. And then the last one, CD, is also adjacent to BC. Okay, and notice they all like have a common point or a common vertex in them. The other thing we talk about is bisect. And so bisect means cut in half or go through the middle. And we will talk about that mostly when we come to diagonals in this case. Okay, so we're going to look at the different types of quadrilaterals. So the one type is a parallelogram. And we're going to define a parallelogram and then write out the characteristics. So this definition part is not in your packet, but you may want to like write it down somewhere. So a parallelogram is a quadrilateral with opposite sides parallel. So that's the definition. There are a few other characteristics that we know about parallelograms. So we know that both pairs, okay, and when we're looking at this, we're talking all about opposite sides. So this is characteristic of opposite sides, this is characteristic of opposite angles, and then we have characteristics of the diagonals. So for opposite sides, we know for a parallelogram, both are parallel. And the other thing we know is that both are also congruent. Okay, so opposite sides are both parallel and congruent. To show that, if you were to draw on a diagram, you would do like the tick marks to show that they're equal. So the same number of tick marks. And then I put them on the side because I'm also going to show arrows. I would show the same number of arrows to show that they're parallel. So the arrows mean that the lines are parallel. And so this shows that the top and bottom are both parallel and congruent, and then the left and right are both parallel and congruent. Okay, for angles in a parallelogram, and I'm going to draw this separate because it gets really crowded. we know that the opposite angles are congruent in a parallelogram. So both pairs of opposite angles are congruent. Okay, again, remember this is always about the opposite. And then when we talk about the diagonals, and again, I'm going to draw that separate for a parallelogram. If I draw them, what we know about them is that they bisect each other. So what that means is that they each cut each other in half so that these two segments are equal and then these two segments are equal. So they bisect each other is the property for a parallelogram. Okay, so that's a parallelogram. So then we have a rectangle. So one thing to note is that a rectangle is also a parallelogram. It's a special type of parallelogram. So a rectangle is a parallelogram, and it's also a quadrilateral because it has 4 sides with 4 right angles. So again, to show those right angles, we show the 90 degrees. Okay, we also know because it's a parallelogram, we know that both pairs of opposite angles are parallel and both pairs of sides are parallel and both pairs of opposite sides are congruent. Okay, and again, this is opposite. For the angles, again, because it's parallelogram, we know that both opposite pairs are congruent, but this week goes a little bit more. We know that all the angles are congruent because they're all 90 degrees. Okay. So again, if you wanted to mark everything, you could mark like the opposite sides equal. You could put the arrows in. I'm not going to put all the markings, it just gets way too crowded. And then for a rectangle, we also know something about the diagonals. So if I draw the diagonals in for this rectangle, we know that they bisect each other because it's a parallelogram. So since it's a parallelogram, all the properties of parallelogram have to be true for a rectangle. We know one other thing about the diagonals, they're also congruent. So they're the same length when it's rectangle. So actually these 4 pieces are all going to be equal because they cut each other in half and then they're also equal. So that's what we know about a rectangle. Okay, then we have a rhombus. So a rhombus is another type of parallelogram. You often think of it as a diamond, but a rhombus is a parallelogram with all sides congruent, okay, or all sides equal. So when we show a rhombus, generally the basic markings is we put 4 equal tick marks on all the sides to show that they are congruent. Now, when we talk about the opposite sides, we know that both pairs are parallel because again, it's a parallelogram. We know that both pairs are congruent again, because it's a parallelogram. But in this case, we go one step further and we say that all the sides are congruent. So then when we talk about the angles, we know that it's parallelogram. So we know that both pairs of angles are congruent. So again, the opposite angles are congruent. Okay, and again, you could put all the arrows for the lines parallel. But again, it just gets really crowded. So usually just putting the tick marks is enough to show that it's a rhombus. Now for the diagonals, we know again that it's a parallelogram. So we do know that they bisect each other. Okay, so we do know they bisect each other, but we also know, and this is not the best diagram, let me try again so that you can maybe see it clearer. No, they don't have a rhombus. Okay, that may be even worse, but if we draw the diagonals, Okay, it's kind of hard to tell, but they should form a 90-degree angle. So we know that the diagonals are perpendicular. They intersect at 90-degree angles. Okay, and then again, we know that they bisect each other. Okay, so then we have a square, and that's usually the one that most people know the most. A square is a parallelogram again. Secondly, also a rectangle and a rhombus, but just we could classify it as a parallelogram with opposite sides congruent with all sides congruent and all angles congruent. Okay, and just note it is also a rectangle and a rhombus. Okay, and of course a quadrilateral, since all of these are quadrilaterals. So anything that's true for a rhombus, a rectangle, or a parallelogram is true for a square. So we know that both pairs are parallel of opposite sides. We know both pairs of opposite sides are congruent, and we know that all sides are congruent because that's the definition. Okay. We know that both pairs are congruent of the opposite, and we know that all the angles are congruent. Okay, so again, all the angles are 90 degrees. Okay, so I could have also said as a parallelogram with all sides congruent and 4 right angles. And then for the diagonals, everything we know about the ones that we talked about, the parallelogram, the rhombus, the rectangle, is also true for the square. So we know that the 4 parts of the diagonals are equal, and we know that they're 90 degrees. So they are congruent, they're perpendicular, and they bisect each other. Okay, so then we have ones that are not a parallelogram. So a kite is the first one we're looking at that's not a parallelogram. A kite is a quadrilateral with 2 pairs of adjacent sides congruent. So we talk about like the short side and the long side. It has 2 short sides that are equal, and it has 2 longer sides that are equal. And so for a kite, none of the sides are parallel, because they're not parallel, and none of the opposite sides are congruent. So we're going to kind of add a note here about like the adjacent sides, the sides that are next to it. So what we know is that it has 2 pairs of adjacent sides congruent. Okay, and that's part of the definition, but that's what we know about the side. So it doesn't fit the opposite sides. We just know that 2 pairs of adjacent sides are congruent. Okay, for angles, there is 1 pair of opposite angles congruent. It's the angle between the short side and the long side. So these 2 angles, if I label them A and B, angle A is congruent to angle B. And then for the diagonals, and this is not perfect because my rhombus is, or my kite is not perfect, but the diagonals are actually perpendicular. Sorry, they're not congruent, they're perpendicular. And the one diagonal bisects the other diagonal. So the long diagonal cuts the short diagonal in half. So it bisects the short diagonal. Okay, so then we have a trapezoid. And for a trapezoid, what we know is a trapezoid is, again, not a parallelogram, it is a quadrilateral. And it is a quadrilateral with one pair of opposite sides parallel. Okay, so one pair of opposite sides is parallel. We don't know anything about opposite angles when we're talking about a trapezoid. So none of these are true. And we don't know anything about the diagonals either. So a trapezoid is pretty basic. If it's just basic, we just know that there's one pair of parallel sides. Again, you could draw it this way as well. And then these would be my parallel sides. Okay, but that is a trapezoid. And then there's one special type of trapezoid called an isosceles trapezoid. And similar to an isosceles triangle is when it's isosceles, it has two congruent sides. So an isosceles trapezoid is a trapezoid with one pair of opposite sides congruent. Okay, and then the other pair of opposite sides is parallel. Okay, and that's because it's a trapezoid. So how it works is that you have one pair that is parallel, and then the other pair of opposite sides is congruent. That's an isosceles trapezoid. So it has one pair parallel of opposite, and it has one pair congruent. And then for the angles, so we don't, again, this is kind of like the kite. We don't really know anything about the opposite angles. We know that it has two pairs of adjacent angles congruent. Okay, so how a trapezoid works is we call the parallel sides the bases, usually base 1 and base 2. And we call the congruent sides legs. And you can also, on this triangle, you could do the same thing. This is a base, this is a base, and this is the leg, and this is the leg. And then on this one, the legs would be here, and the bases would be here. But what we talk about it is that the base angles are actually congruent, or it has two pairs of adjacent angles congruent. So the two bottom base angles are congruent, and then these two top base angles are congruent. Okay. And then for the diagonals, there is one thing we know about diagonals. The diagonals are actually congruent, only if it's an isosceles trapezoid. If it's just a trapezoid and not isosceles, we don't know anything about the diagonals. Okay, but in an isosceles, they are congruent. And if you can draw these more to scale, you can probably see the properties of the diagonals a little bit better. Okay, so the last part of it asked you to make a word explosion, and I'm not going to do it for all of them, but it's just to help you review the properties of the quadrilaterals and maybe help you remember them. So when you do a word explosion for math, what you would do is you would pick the quadrilateral talking about, so the rectangle, and you would put like a circle around it, and then you would do kind of branches around it with all the properties. So for a rectangle, you could say like 4 right angles. And then opposite sides congruent. Opposite angles congruent. Diagonals congruent, and then bidiagonals bisect each other. Okay, so you can just like do that for each one to help you review the properties of the quadrilaterals. Okay, so that's the video on the quadrilaterals. Mostly make sure you just know all the properties for them.